Alright, so the next rule is called the power rule. And the power rule is one of those rules that, again, we're going to be using throughout the remainder of the semester, and you're going to be using throughout the rest of your studies. If you continue to study math, you're definitely going to keep on using it. So this is called the power rule. And the power rule says the following: if n is a real number, then the function f of x equals x to the n is differentiable, meaning the derivative exists, and the derivative in terms of x of f of x, f of x here is x to the n, so I could just use x to the n, of x to the n is equal to n times x to the n minus 1. And for this particular function f, for f to be differentiable at x equals 0, then n must be a number such that x to the n minus 1 is defined on the interval containing 0. Right, so this is the so-called power rule. Now the power rule is very important. I'm not going to prove it because it'll take some time. You could find the proof anywhere online, really. Most of these things in Calc 1 you can find online. He already makes videos on them, so I'm not going to bother proving it. However, I will show you some examples of what the power rule says. Power rule says that if you have the following scenario, let's say f of x equals 3x to the fifth, then the derivative of f prime, is going to be what? Is going to be n times x to the power n minus 1. Well, what is n here? And I actually began with a more difficult example than I needed to, so I'm going to remove that 3 from there. N here is 5, so f prime of x is going to be equal to n times n minus 1, but n here is 5, and n minus 1 is 5 minus 1, which is 4. So that means that f prime of x is equal to n, which is 5, times x to the 4 by the power rule. Again, let's do one more. So g of x, and let's say g of x equals x cubed. Again, n is equal to 3. That means n minus 1 is equal to 3 minus 1, which is 2. So we have that g prime of x by the power rule is going to be n times x to the n minus 1. But we know that n is equal to 3 and n minus 1 is equal to 2. So we have 3x squared. Let's do another one. Let's say you were given g of x is equal to the cube root of x. Well, for this particular problem, I always say, you might want to rewrite it so you can see it clearer. The cube root of x is the same thing as x to the power 1 over 3. Okay? So now here we can see that n is 1/3. That's the exponent. And again, my apologies, my n's and h's look alike. And that doesn't even look like anything. So n minus 1 is going to be equal to 1/3 minus 1. But remember, to combine fractions, we must make the denominators the same. That's the same thing as 3 over 3. So it's going to be 1/3 minus 3 over 3. That's going to be negative 2 over 3. Okay? So that means that the derivative, g prime of x, again, by the power rule, is n times x to the n minus 1. Well, n is 1/3, so g prime of x is 1/3 times x to the power -2/3. Now, we never want to leave the uh, the function in non-simplified terms, so I'm going to simplify it by simply bringing the x into the denominator. Remember that when you have a to the negative n, that's the same thing as 1 over a to the n. The n is positive, so this is going to be the same thing as 1 over x to the 2/3, 2/3. But that's the same thing as when you multiply across, you multiply the 1/3, you multiply 1 times 1, that's 1. 3 times x to the 2/3 is just 3x to the 2/3. This is a more challenging example, but as you can see, we can, by following the power rule, we can actually find the solution. Let's do another one, just for the sake of it. 4. It's 4, yeah, 4. Let's say k of x is equal to 1 over x squared. Well, here, what I suggest, again, rewrite it. So this is k of x equals x to the minus 2. In this case, we're going backwards using this rule again. And now you can see that n is going to be equal to -2, and n minus 1 is going to be equal to -2 minus 1, which is equal to -3. So the derivative of k in terms of with respect to x is the same thing as n times x to the n minus 1, which means that we have n is equal to -2, x is equal to -3, so it's -2 times x to the -3. And again, let's simplify that a little bit more. This is going to be -2 times 1 over x cubed, which is the same thing as -2 over x cubed. Then you simplify across, so 1 here, you multiply across, and you get your solution. Alright, so I'm going to do 2 more examples, a bit more challenging. Let's find the slope. So in this example, let's find the slope of the graph of f of x equals x to the 4 when x equals -1, x equals 0, and x equals 1. Remember that the derivative gives you the slope of the tangent line at a particular point. Always keep that in mind. That we learned from lecture 8. The derivative tells you the slope of the line of the function at a particular point. So if I was looking for the slope at x equals -1, then I could take the derivative and then evaluate the derivative at that particular point. So that's what I'm about to do. First of all, what is the derivative of x? Let's do it the slow way. So f of x equals x to the 4th. Again, n equals 4, n minus 1 is 4 minus 1 is 3. I'm going to take it slow for these problems. So f prime of x is going to be equal to n times x to the n minus 1, which means that f prime of x is equal to 4 times x to the 3. So we have 4 times x to the 3. That is the derivative of f. So when x equals -1, we have f prime of -1 equals 4 times -1 cubed. I'm simply evaluating the value of x -1 on the derivative. Okay? And that will give us the slope of the graph at that particular point. So notice that -1 cubed is just -1, so it's going to be -4. Okay? So notice that the slope here is negative. This is going to be important later. The slope here is negative. How about when x is, what was it, 0? Yeah, 0. So when x is 0, we have the derivative evaluated at 0. F prime of 0 is going to be equal to 4 times 0 cubed. But 0 cubed is just 0, so that's 4 times 0, which is just 0. So here, the slope is 0. And finally, when x equals 1, we have f prime of 1 equals 4 times 1 cubed, which equals 4 times 1, which is 4. So here the slope is positive. Okay, so we want to make sure that we identify when the slope is negative, 0, or positive. That's going to, again, play a big role in a couple of weeks. So keep that in the back of your head. Now, what if we wanted to write the equation of the tangent line? Like what if we actually wanted to write the equation of the tangent line? So let's find the equation of the tangent line. To the graph of f of x equals x squared when x equals minus 2. So if you remember what that looks like, that's just a parabola, and at minus 2 we have 4, because minus 2 squared is 4. So we're looking really at the tangent line that goes like this, and 4. We're looking for that slope. Intuitively, you should realize that this is going to be a negative slope. It has to be, because that line is going down from left to right. So that has to be something that looks like minus ax plus some b, okay? Where the slope is negative, because you're going down from left to right. So that's a big hint right there, because if you get a positive number, then you know you did the problem wrong. So first of all, let's take the derivative. So let's take the derivative of f. So f of x is equal to x squared. What is f prime of x? F prime of x is going to be, well, n is 2, n minus 1 is going to be 2 minus 1, which is 1. So we're going to have n times x to the n minus 1, which means that f prime of x is going to be equal to 2x to the first. I'm not going to write to the first because it's redundant, but we have 2x. Now, to find the slope at this particular point at negative 2, we simply have to plug in negative 2 into the derivative. Remember, we're plugging in into the derivative to find the slope. So that means that I have 2 from the formula times minus 2. Last time I checked, 2 times minus 2 is minus 4. So as I just mentioned, the slope is indeed negative, so slope is negative. Now, remember, to find the tangent line, the equation of the tangent line, we need to use the slope point formula. Which is y minus y1 equals m times x minus x1. All right, but remember, to use this formula, we need a point on the line. We need a point on the graph. Of f of x equals x squared. We don't have a point right now because we only have the x equals minus 2 piece from the problem. That's all we were given. But we could actually find a point on the graph by simply evaluating the original function at minus 2. So if we evaluate at minus 2, we have f of minus 2 is the same thing as minus 2 squared, which is 4, as I told you before. It's 4. And now we have the point negative 2 comma 4. So I call this P. And now I can actually find the the tangent line. So tangent line is going to be y minus y1 equals m times x minus x1. It's always good to rewrite it. It helps you memorize it. My y1 is 4, my x1 is -2. So I have y minus 4 equals m. Remember, m was the slope that we found up here, and that slope was also -4. So equals -4 times x minus, and then we have -2 for x, so -2. You could leave the problem like this. If I don't ask you to simplify, you could leave it like this, and it's completely fine. But just for the sake of argument and practice, let's just simplify this. So this is going to be -4, and then +2 times -4 is -4x, and then +2 times -4 is going to be -8 plus 4. So that means that y equals -4x minus 4. And this is, so y equals -4x minus 4 is the equation of the line tangent to f of x equals x squared at x equals -2. And this is how you will go about solving one of these problems. All right, thank you for your attention.